up, coders, debuggers, and troubleshooters? In this video, we're going to learn about one of the most interesting concepts in programming, especially in C language, and that is recursion. We'll talk about what recursion actually is, what programmers use, how to write recursive function, and I'll show you two simple and clear examples, a countdown and a classic factorial function. So by the end of this video, you'll fully understand how recursion works, what a base case is, what a recursive case is, and the most common mistakes to avoid. So let's get started. So first things first, what makes recursion useful? But before we answer that, what is recursion? So recursion is a technique where a function calls itself to solve smaller versions of the same problem. So instead of writing long loops or complicated logic, we break the problem into simpler parts and let the function repeat the process automatically. So now that we know what a recursion is, how is it useful or helpful? So recursion is very helpful in situations like mathematical problems such as factorial or Fibonacci, processing tree-like structures, searching and sorting algorithms, and problems that naturally break down into smaller subproblems. And one of the biggest advantages of recursion is clarity, as some problems become much easier to understand when written recursively. But recursion also has disadvantages, as it uses more memory because each function is stored on the call stack, and if written incorrectly, it can be slow or even crash the program. So recursion is powerful, but it must be used carefully. So to write a correct recursive function, we need two essential parts. The first one, the base case. What is the base case? So the base case is the condition where the function stops calling itself. Without this, the recursion would continue forever and eventually crash the program. And the second one is the recursive case. The recursive case, on the other hand, is where the function calls itself again, but with a smaller or simpler output. Each recursive call should bring us closer to the base case. So here's the basic pattern. If the input's at its smallest form, it should return a direct answer. But if it doesn't, call the function again but with a reduced version of the problem. As long as we have a base case and a cursive step that moves towards the base case, the recursive will work correctly. This is the foundation of all recursive functions. Okay, so let's start with a very simple example. So let's count down to 0. So here's the code that we'll be using. Okay, so as you can see, this is the code that we're running with, a pretty simple countdown code. It's fairly simple. I did mess up one time. There was a error, but that was my own fault for forgetting the semicolon and replacing the dash for a underscore, but we all make mistakes. So once you run this, the output shall be 5, 4, 3, 2, 1, and then done. And the reason for that is because I used a equal operator. But if you want the output to have a 0 after 1 and before done, all you have to do is just replace the equal operator with a greater than sign, and once you run that, the output should finally have the 0 at the end. Okay, so now that we have the code, let's walk through it. The base case is when n equals 0, and at that point we print done and return, stopping the recursion. Otherwise, we print the current number and then we call the same function again, but this time with n-1. This makes the input smaller each time, so eventually we will reach 0. If we call countdown, parentheses 5 parentheses, it prints 5, then it calls itself with 4, prints 4, then 3, then 2, then 1, and then finally 0 and prints done. So this example is perfect because you can clearly see how each call depends on the next and how the recursion moves steadily towards the base case. Okay, since we're done with the countdown example, let's now take a look at a classic problem that is almost always taught in recursion, which is factorial. So mathematically, the factorial of a number n, which is written as an exclamation, is defined as uppercase N exclamation n x open parentheses n dash 1 closing parentheses and exclamation. And the base case for it is 0 exclamation equals 1. So the recursive version of this in C. So once again, here's our given code for the factorial example. Just another simple code. I won't go much into detail about this code as I will be explaining the flow just right after this. So this is just to show you how it was made. Feel free to try it out yourself, and I will be explaining the flow now. Okay, so now that we have our example code, let's now break this down. So if n is 1 or less, we simply return 1, and that's our base case, which stops the recursion. But if n is greater than 1, then we return n times factorial parentheses n dash 1 parentheses. So this just means I don't know the answer yet, but I know that it's n times the factorial of 1 less. So basically, let's say we start at 4, it starts calling the numbers down back to 1. So for example, 4 times factorial 3, it will then become 3, which now it's 3 times factorial 2, and then 2 times factorial 1, and then once it reaches 1, it'll return back to 1. But after that, everything then multiplies back up. So basically, we just broke things down, and now we're gonna build it back up. So now we have 2 times 1, which is equals 2, and then we're gonna take that 2, and then we're gonna put 3 in front of it and multiply it. So now 3 times 2, which is now 6. Then repeat the process, and we have 4 times 6, and now we have 24. So now the factorial of 4 is 24. The example just shows how recursion builds results by breaking them in, or the problem specifically, into smaller pieces, and then combining the results as the calls return. So before we end all of this, let's quickly cover the most common mistakes that people make with recursion. So the first mistake is the missing base case. So as we discussed earlier, with base case, without it, the function never stops calling itself. It keeps going deeper until the program runs out of stack memory and just crashes. So yeah, because the base case is the exit door, which prevents the program from just crashing. So if you forget it, it just guarantees infinite recursion, which is, not good, because as we discussed, it crashes. The second mistake is the base case that never happens. So here, the base case does in fact exist, but the function changes to the input as it never actually reaches the condition. This often happens when the input moves in steps that skip the target value, like subtracting 2 but expecting to land on 1, as the result is still infinite recursion because the stopping point is impossible to reach. The third common mistake is the wrong base case condition. So the base case is present, like in mistake 2, but it doesn't cover all valid situations, as for example, stopping only at 1 when the input can also end at 0. This creates errors, crashes, or incorrect results because the recursion doesn't stop when it logically should. The fourth mistake is unnecessary recursion. My bad. So some problems simply don't benefit from recursion. Using recursions where a normal loop is easier can make the code slower, harder to read, and even more memory heavy. So recursion should match the problem structure. If it doesn't, it's usually better to just avoid it. And then for the last mistake, it is very deep recursion. So even when recursion is correct, the call depth might become too large. Each call uses stack space, so extremely deep recursion can still crash the program, as this happens often with large inputs or inefficient recursive designs. And that about wraps things up. I hope you at least learned something new that you may use in the future. If you do want me to tackle something else, please comment down below and I'll make sure to tackle it in another video. But before we do end it off, let's do a little recap, shall we? So to recap things, recursion is when a function calls itself to solve a smaller version of the problem. as we discussed earlier. Every recursive function needs a clear base case and a recursive case that moves towards the base case. Also, that we looked at two examples, a simple countdown and the factorial function. This is to show how the recursion works both in structure and in practice. And if you want to practice, try making your own recursive functions such as reversing a string, or strumming a list of numbers, or exploring binary trees. Once again, thank you for watching. I hope this helped you understand recursion clearly and easily. And remember, as always, never stop coding. So I'll catch you guys on the flip side. See you on another video. Bye bye.